All right, we're live. Cool. Thank you all for joining on this Tuesday morning in New York, at least. So this is our first official lecture, which is exciting. I think the format we're playing with, and I think I mentioned this last time, like some lectures are going to be more Web3 heavy, some lectures are going to be more SQL heavy. This lecture is mostly Web3 heavy, I would say. The SQL that we cover today um, won't be too insane. Um, yeah. So that being said, I am gonna have kind of pause points for questions. So if you want to type your questions or hold your questions till then, either is fine. Or if you're completely lost, then feel free to interrupt me. But hopefully that'll be good. That being said, so what we're going to cover today, I'm just going to go over what the Web3 raw data landscape is, and you'll see what I mean in a second there. And then we're going to break down all the transaction from all the data from an Ethereum transaction, and essentially look at how that data is placed into SQL tables. And if you don't know what a SQL table is, I'll explain that when we get there as well. Then we're just going to do a quick overview of the Dune interface. And lastly, we'll do some basic SQL queries on Rabbit Hole's quest data. I'm actually going to move you guys over here. All right, cool. So I'm not sure how many people here are familiar with what a blockchain client is, or how nodes on a blockchain are run. Specifically, Ethereum runs through clients like Geth. So if I go to Go Ethereum, I can actually see this implementation of Ethereum, right? And I can run this on my own computer. So just kind of show how that works. I'm just gonna copy this command from yesterday. And essentially, this is like a command line interface. And what I'm doing here is like it's almost kind of like you downloaded Microsoft Word and you're just running Word locally, right?
Just a second,
Um,
Andrew. Are you sharing your screen?
oh
Sorry to
crap!
interrupt, but
I'm
are you
not.
sharing your screen? Yeah.
Sorry. Thank you.
They will see anything.
I started recording, but I wasn't sharing my screen. All right. Stepping back, that was just the intro screen. I was saying this is what we're going to be covering today, these four parts. All right, yeah. So this was the diagram, basically showing. We start off with Ethereum clients, right? So one example of an Ethereum client is Geth or Go Ethereum, which is this repo you can find on GitHub, right? And essentially, this is like software you can download and run on your own computer, and it doesn't rely on having any other kind of like middle services to kind of run, right? And what I was showing was this command line interface where essentially I can run this repo on my computer, and I'll actually be able to see the blockchain running in this interface here, right? So this is actually connected to the Ethereum blockchain right here. So this is like the highest effort way of connecting to the blockchain and like accessing data on the blockchain. So I could access this through something called localhost, which is basically like your own local server. So obviously, no one is going to be doing this for querying data, but it's kind of good to know, like, okay, at the lowest level, you run a client, and the client kind of syncs with everyone else who's running a client to get the data of what's happening on chain, right? So the next level up from running a client is actually using kind of a node endpoints as a service provider, right? So this is services or companies that run their own set of nodes with these exposed endpoints, and basically they allow you to query those endpoints, right? So fun fact, so Infura, Alchemy, those are like two of the big ones. And if you go into your MetaMask wallet, you can actually go, I think it's in settings. If you go, yeah, so if you go click this button and then you click settings and you go to networks and then you go to your Ethereum mainnet, you can actually see that this is the URL being used, right? This is your node endpoint as a service. In this case, it's Infura, which makes sense because Infura and MetaMask are both part of consensus. And yeah, so basically anytime you're connecting your wallet on some website or some dApp or whatever, you're connecting through this node endpoint as a service, right? And what I could do is I could take my localhost endpoint from the client I'm running on my computer, and I could put this in here as well, and everything would work the same, right? And something I'll specify for both of these, you can not only read data, but you can send data. So you can send a transaction, right? That's pretty key, because once we go one level up, everything becomes essentially read only, right? So all of the data here at these two levels runs as basically an API. And anyone who, if you don't know what an API is, essentially it's like you can only get like one piece of data at a time. Like you can only get what is your Ethereum wallet balance, right? Or you can only get like what is the current block number. You can't query these two with SQL, right? If you wanted to query with SQL, then you have to go to a data mapper, right? Basically like Dune, where Dune will take all of the data, likely, I don't know Dune's setup specifically, but I'm assuming they probably use some sort of node endpoint like Infura to kind of read data from the blockchain and put it into SQL tables. And if anyone's familiar with the graph is kind of the same thing, where they take that blockchain data through some node, and then they format it into a table that can be queried with GraphQL, right? So we're going to be working with data from here, but I think it's helpful for people to understand kind of like where, like the hierarchy of where that data came from, right? And if this doesn't really make sense, then that's okay. But I just found it helpful, and I've gotten a few questions on like, hey, what do I use to get the data, right? And I call this raw data because on all three of these levels, you're accessing like the base transaction data, essentially, right? You're not like, it's not like someone has put together some data report on like all of Uniswap's like swaps or something like that, and you're just downloading that, right? That would be something like Nansen instead. All right. I know that some of you probably have questions on that, but I want to get through the next section and then we'll come back to that. Okay, so this one we're going to spend some time on. Who here has probably transferred some sort of like ERC20 token, like USDC or Unitoken? Few people have, right? Okay. Hopefully. All right. If you don't know what an ERC20 or USDC token is, that's okay. We're going to cover that stuff on Thursday when Kofi goes through kind of some of the token standards. But essentially, just think of it as like someone's transferring like a US dollar on the Ethereum blockchain, right? And I won't go into the Solidity or contracts yet, right? But
Andrew, can you throw this into full screen?
Yeah, it's too small. Okay. Let me present. Is that better?
Yeah. Thank you.
Yeah, of course. So if you don't know what USDC is, just don't worry about it. You just think of it as there's a US dollar on the blockchain, and someone calls a transfer function where you're specifying who's receiving that US dollar and then how much of that US dollar you're trying to send, right? That's all I have to know for now. We'll go through the Etherscan and like Solidity in a second. But essentially, you can think of it as when I'm transferring a token, I have to sign that transfer, right? Hopefully, anyone who hasn't gone through like MetaMask or transaction signing, hopefully you can do that soon, or I'll help you out with that. But after you sign a transaction, that sends it to the blockchain, and now blockchain sees, okay, this wallet has called a transfer function, and that's going to give you something called call data and a signed transaction, and it's also going to give you sub interactions, right? This sub interactions, this is going to be somewhat confusing at first, so like just pretend this doesn't exist for now. The main body is going to be this left side, right? This is your call data of like, all right, this function was called on some contract, right? So that data has to be stored somewhere. And this was signed by some person with some sort of signing parameters, right? So that's stored as well. And essentially what Dune does is it creates a table called Ethereum.transactions. Transactions is the table name. And it has these essentially 8 columns, right? It has a from parameter, which is who sent the transaction or the signer. It has a to column, which is the address of the contract interacted with. So in this case, this would be the address of USDC, because it's a contract that sits at an address. There's a success state. Sometimes transactions fail, so even if it fails, you'll be able to see it on the blockchain. There's a value column, which is the Ethereum value that was transferred from the signer. All right, so in this case, I'm transferring USDC. I didn't transfer any ETH, so this value would just show up as 0. There's gas columns, which I won't go into now. There's call data, which essentially tells us that this function was called, and we'll dive more into that. There's a transaction hash. So every action done on the blockchain has a unique hash. And we can get into hashes later as well, but just think of it as like a cipher, like it's randomizing stuff. There's a block number. So for anyone who isn't familiar, Ethereum, like everything's done in blocks, 15-second blocks, and every block stores a certain amount of transactions like this one. So this is essentially just telling us when the transaction happened. I know that's a lot, so let's actually go to Etherscan and look at an example. So anyone who's not familiar, Etherscan is like the easiest way to search up everything that's happening on the Ethereum blockchain. And there's a bunch of different scans for other chains as well. But what I can do here is I can search up USDC, and it's going to actually bring me to the USDC contract. All right. So if I click that, don't worry about all of this right now. All you can see here is that there's been 28 million transactions found, which more or less probably means that there are 28 million transfers, or 14 million, but we won't go into the nuance of that. So what I can do here is if I go to last, let's say I pick a random transfer here, right? This person sent 1,000 USDC, and this is the address that they sent it from, right? And then this is the address that they actually transferred the tokens to. What you can see here is this basically matches up with the columns we had over here in this table, right? So again, this is the signer, this is the block number, this transaction succeeded, this is what a transaction hash looks like, right? Again, this is an important part. This is the contract that was called, and you can see the call data or the function that was called if you click to see more. There's this input data, right? And you can see that this function transfer was called. Obviously, this has already been decoded. What you would see technically, or what the blockchain sees, is this, right? And we'll go over how that decoding kind of works as well. So that was this first step, right? This is the transfer, just stores all of the data of kind of sender and like what happened, what was called. The next kind of big step is called an event emission or event log, right? So typically you don't want to just filter through like all of these event calls. That's actually a lot of API calls. Remember earlier when I was saying that if you run either Infura or like Geth, everything is like one API endpoint to call for a specific thing. So if you're just trying to call for all of these, like for this transaction, what was the call data, that gets pretty expensive. So what we've created instead is Ethereum has logs, right? This is kind of just like, it's like a notepad of like every single action that's happened, right? So inside of this transfer function, this emit transfer event is called, which essentially emits who the sender was, who the recipient was, and who the what the amount transferred was, right? So we can look at logs here, and you can see the sender was this address, the receiver was this address, and the value here actually shows as I think this is like 1 billion, right? And earlier you remember that it actually said that only 1,000 was transferred. And we'll get into why this shows 1 million instead of 1,000 when we get into queries. But just to kind of show off again, this is from, right? This is your sender. Shows up here as your sender. This is your to, the receiver. Note that this to is different from the interacted with to, right? The interacted with to is the contract address. And lastly, this topic 0, this is actually like it's like the what should I call it? The signature, not signature, the identifier related to this event, right? So anytime, like if I just wanted to look for all transfers of USDC, for example, I would just look up this kind of event topic. It's like a control F essentially, and I'd be able to see, oh, okay, for transfers, this is everyone who transferred from person A to person B and like all the money they've transferred, right? And you'll notice here that this is actually stored all as topics as well, which is kind of confusing naming, but you can just think of topics as like variables in our case, right? So if you look here, essentially all you're storing in this logs table is there's a contract address that the event was emitted from. Topic 1 here is that event signature that I was talking about. And topics kind of 2, 3, 4, and data are like the other parameters that were emitted in this event log. All right. And essentially, these tables can all be linked by transaction hash. Typically, like that's almost always the easiest way to link across these. And we'll get to what linking means in a second as well. I should note here that SQL tables here, you can, if you don't know what SQL table is, you can kind of just think of it as like different Excel sheets. That's probably the easiest way of thinking about it, where they have an Excel sheet where like these names are like the top row, and then like each transaction is like a row kind of following underneath it. And everything we do on Dune basically is going to be constructed from these 3 tables. Cool. All right. I know that was a lot, so I do want to put a pause point on if anyone has like conceptual questions about like what the heck I just explained. or if you're just completely lost at all. Or if you get it.
What are traces? Could you talk about them?
Yeah. So traces are confusing. Essentially, you can think of like, if you look in Solidity, you can actually call contracts from contracts, right? So if I have like a contract that manages like an escrow, for example, like I put in 50 USDC into this contract, and like someone else can call that contract to like move the 50 USDC out or something. Technically, that's calling 2 contracts, right? One, it's calling that escrow contract, and then 2 would be calling this USDC contract to make that transfer, right? So it's kind of like 2 levels. So when there's a secondary call kind of done, like when it's like, there's like different call types for it, but like if you're calling another contract, that'll show up sometimes as like an internal transaction. That's one way you can end up with this kind of like multi-call structure. And the reason why there's a delegate call showing up here is because USDC is actually implemented as a set of contracts instead of your typical just single contract structure. It's called a proxy structure if anyone wants to search it up, but I wouldn't spend too much time on that. We'll get into better examples of what traces looks like in the future. Typically in data analysis, when you use it, is going to be looking for like transfers of ETH, right? So if you transfer ETH from one person to another, it's actually going to show up as an internal transaction, because that when you transfer ETH, it's not technically interacting with a contract, so it shows up as internal. It'll show up as a call. I don't know if that's super clear. I think traces take some time to kind of wrap your head around. So just focus on transactions and logs for now. I just included it here so that you kind of have it as reference for later.
So would this be if a platform or protocol has multiple transactions that call in each other, or like multiple contracts that call in each other, or if an OpenSea contract, or if like a platform that I don't know, something like Genie is calling the OpenSea contract?
Right. Hold on. Let me double check real quick. I know for certain calls it does release. Give me 1 second to find a good answer. Yeah, I'll put this in here as well. I should have done that on screen. But essentially, you can just search up this on Stack Exchange. And they're explaining here how essentially you're feeding data from one contract to another. So yeah, in your example, yeah, that should show up as an internal transaction.
I got a question here. Is there any rhyme or reason to the structuring of the hashes or the contract addresses, or is it just a random conjunction of of letters and numbers?
Yeah, that's a great question. There's actually, I put this deep dive in here that explains more of like why we have hashes and like how they kind of roll up to each other. The way you can think of it as like hashes are an efficient way of storing data, right? So if I hash two numbers with some algorithm, those numbers are always going to hash into the algorithm, hash into the final thing, right? So if I let's see, let me go to Miro. Actually, no, I should just do this. This gets into something called a Merkle root, where essentially, if I have some set of numbers, right, and I hash it, these hashes are always going to be the same the whole way up. So essentially, all of the transactions in a block will get hashed together until you get to this top, what's called like a Merkle root hash. And essentially, that's like a very, very like lightweight way of storing all the transactions that happen in the block. And so like your block hash is somewhat based off of your transaction root hash as well, right? So you can think of like if there are 50 transactions in a block, they would each be paired up and then hashed up and then paired up and hashed up again until you get this last one. So they are random, but there's a reason why they exist, right? And this is how they keep the blockchain so small, right? That's why I can just run it so easily on my computer. Otherwise, if it was stored as like normal data is stored, where it's like in a string or just a number or something, the blockchain will get way too big for me to run on my computer, right? It might become like terabytes big, essentially. But keeping it in these single hashes, like you can imagine, oh, it's just this hash per block, that's a lot cheaper to store over time.
Correct. All right, thank you.
Yeah. And if you're curious about the hashing algorithm, it uses something called SHA-256, which you can read into the history of that as well, because that's actually very interesting. Any other questions? Or something that anyone wants me to go over again? Cool. All right. Let's make this more clear. I think like this is what I experienced when I was first learning about this stuff. Like reading doesn't help that much. It's like once you start going into the data and like doing a few queries, I think it all comes together a lot more because you're like, oh, the data makes sense. The data flows. So here I'm showing the Dune query interface guide. This is mostly here for you to reference back to if you get confused about the UI at some point. I'm not going to walk through this one by one now, since we can just do it here. But I will just say the main confusing part, I think, for people is like what is going on this left side. And these are essentially like your function calls or your event logs from different contracts, right? So this is like the event logged from this Aave contract. And basically all smart contracts are kind of stored as data tables, where like every single function or event from that contract is its own table. But it's built up from these three main tables that I was talking about over here. Right? So don't worry too much about this now. Most of what we do in the following weeks is going to be relying on this rather than relying on building things up from these three tables. But we're just going to pretend that this doesn't exist right now. All right. So, all right. Now let's get to the fun part, since we've gone past some of the most confusing parts. So this is a transaction hash, right? So what I'm going to do is I can look at the Ethereum transactions table and look for this transaction hash, right? But before I do that, actually, just breaking down how SQL works, right? So in SQL, most important two words are select and from, right? So from is what table are you querying? In this case, we're querying the table of all Ethereum transactions. And select here is what columns from that table do I want, right? If you ever see a star here, star means all. So star means, okay, I want every single Ethereum transaction, right? And what I can do is press run or press control enter or command enter, and it'll start running. And this query is actually probably going to end up taking a while because, as you can imagine, like there are millions of Ethereum transactions. And if I just try to call and load every single one of them, that's going to take a very long time. I think this actually probably time out. So I'm going to cancel this. And what I'm going to do is I'm going to add something called a limit. And you can think of a limit as kind of like a magnifying glass of like, how far down do I want to look? So I want to look at only the last 10 Ethereum transactions, right? Or this might give me the first 10 actually. Yeah, the first 10 Ethereum transactions in this case. And you can see that loaded a lot faster, right? Because all I had to do is go to this table, take all the columns, and select only the first 10 rows, right? And you can see now that these columns are essentially the ones that I was showing here, right? So each of these rows is its own transaction. And you can see that because the hash is here, right? So I can take any of these hashes. I can go to Etherscan, which seems to be a little slow today. And I can paste in that hash. It's normally not this slow. All right. And I can see like when this transaction happened, the block number, like they transferred 1 ETH, and they didn't interact with any contracts here. All right. So I can search up basically all of Ethereum's transactions from here. There's actually a good chance as well. Oh no, it doesn't have internal. Never mind. Cool. So now getting back to this star, right? I said this is a column selector. So what I can do is say, all right, I only want the hashes for some reason. So I can say, just give me the hashes. And I'll give me just that one column. All right. Something else important to note is, why do I have these quotes? For now, you just think of it as like, anytime you're selecting a column or a table, you should have quotes, right? And if you're ever typing something, and we'll get to this in a second, if you're typing a variable or something, or like a string, then you don't need quotes, because this is just text. And you'll see it just shows up. It says, doesn't know what this column is because it doesn't exist, and it just pastes hello world 10 times, right? And we'll dig more into that in a bit. All right, so let's go back to originally what I was saying. Let's look at this specific USDC transfer, the one that was for $1,000. So I'm going to take this transaction hash, I'm going to copy it, and I'm going to introduce the where function, essentially. So once you've selected your columns from a table, you can say, all right, I want these columns, but I only want certain rows. I only want the rows where the hash is equal to this transaction hash, right? And if I run this, probably actually fails right now. That's because byte this is a data format called bytes, and in SQL it doesn't do a 0x, it does a /x, right? So anytime you copy something over, just remember change this 0 to a slash, right? That's very important. Let me delete that. All right, so I'm gonna save and run.
I have a question.
Yes, go ahead.
But why not the table store it as a string, but a byte?
Yeah, so sometimes you'll get a bug, and you have to cast it instead. In this case, it's recognizing that this is a bytes variable. But that's a good point. Data types are probably something else that's a headache that everyone's going to have to learn. I guess I can go through some of them now. So like this is a data type. This is an integer, right? This is bytes. This is something called a Boolean. And I don't think there are any strings. I guess this is a string. So typically if you try to work with different data types, like for example, if I put like, I don't know, like 100 here, it's going to say operator doesn't exist, byte A equals integer, right? And why doesn't that work? It's because I'm trying to say, look at where this hash is equal to 100, but hash is of the bytes type, and I'm trying to compare it to an integer, right? So I think, sorry, I didn't catch who said the question, but his question was, why doesn't this throw an error, right? Because this looks like a string, which should throw an error, but SQL's a little, it's a little bit smarter in this case. But if it didn't work, essentially what you'd have to do is cast it to another type. Basically tell the computer what type of variable it is. And you do that with these double dots. And you say double dot byte A, right? Don't worry too much about casting for now. We're going to get into that in a second. But yeah, so right now I run that and it'll show me basically exactly this transaction. I'll put it side by side just so we can see it, right? You can see the block time was October 24th. You can see the from was from FE something, right? Over here. The contract was 0xa 0b, which you can see that's the same contract here, right? So here we have everything. Except you're probably gonna, oops, sorry. Boxer, I think you got a lot of background noise over there. Sorry about that.
Sorry, sir. Yeah, you're not side by side. We only see your Dune window.
Oh, okay. Give me a sec. All right, is it working now?
Yes.
All right, cool. Yeah, so I was just showing the block time matches the block time here. Your from signer matches your from here. The contract you interacted with, which is USDC, matches here. All right. And the value, of course, is 0 because no ETH was transferred. And we're going to get into this in a second, but you're probably wondering, how did they get this tokens transferred here, right? Like, how do they know it's 1,000? Because we don't see 1,000 in here anywhere. And that's because they actually already decoded it from this function signature, right? Which I will decode in a bit, but let's not get into that now. Does that make sense? Basically just showing we're querying all transactions where the hash equals this transaction hash. Yeah? Cool. All right, I see nods. All right, so that's where, that's limit. So what does this transaction hash look like if I look at traces instead, right? So again, this is basically the same thing, where I'm selecting everything from Ethereum traces. I've added this TR here. Essentially all that means is I can rename this to some variable, and then I can use this variable to call certain column names. This becomes important once you have multiple tables. So this just saves me from having to write like this essentially, right? All right, so if I look here, I'll see there's this subtrace, right? And this is that call to another contract that I was mentioning earlier. So right now this doesn't really give us any value, so like there wouldn't be any use to us querying this, right? It doesn't tell us anything. All right, now the important one. So if we look at the event log, right, which is ethereum.logs, right, I can see here the topic. This is your transfer event hash, right? And basically there's topic 2, topic 3, and then there's data. All right, so if I look back here again at logs, you'll see there's an address from is this topic, and then there's an address to, which is this topic. Note that in Dune the numbers are shifted by 1. So this topic 2 is actually this this one. Hold on. This topic 2 is topic 1 here technically. And what we can do here is see, okay, if I wanted to see the value that was transferred, right? Here it says data. It actually shows up as this hexadecimal. So what I'm going to show right now is, actually, hold on, give me a sec. Am I on the wrong chain? Sorry, I'm not. I think I have the wrong, yeah, okay. My bad. So what I was checking for there was why does this data not match this data, right? Here it's 3B9, and here I was saying 5D1. And that's because I had a different transaction hash pasted in here, right? So I just copied it over, so now we should see that it's actually right. Yeah, now it's 3BD. So again, this is just bytecode, right? But we might want to see what does that actual bytecode look like in numeric form, right? So I'm going to select the data column, and I'm going to apply a function to this data column. I'm going to change it from bytes to a number. And there's a built-in function here called byte to numeric, and I can apply it to the data column, all right? So let's say I do that. That's basically showing me that this column converts to this number, right? And there's a bunch of different kind of column operators and functions like that. What I can do here is I can actually divide here as well. So the reason why this shows up as 1 billion is because there's no way of storing decimals on chain. So instead of storing decimals on chain, you kind of pad things instead. So if you want something to go to 6 decimals, you pad it with 6 zeros, right? So you can see if I remove those 6 zeros, I get back to my 1,000. So if you start doing some data analysis and you're like, these numbers don't seem right, why are people transacting in the billions? That's because you have to divide by decimals. And there's a table for making that easier, but for now I'm just going to do it manually. I'm going to say, let's divide by 10 to the 6th, right? And that gives me 1,000. Written in short form, you can write 1e62, that's like scientific notation. And you'll see here that this still says column unknown. That's because I applied a function to it. Basically, when you start applying a function to things, it messes with the column name, so it doesn't say data anymore. So just the same way that I rename this table, I can rename this column as data translated or something like that. And that changes this column name. Any questions on this part?
Do we have any aggregated data or aggregated tables where we don't have to do these things
Yes.
again and again? Or
Yes, of course. So that's a very good question. You're asking, all right, it's going to be annoying to basically do this on like every single like table, right? And so that's what this was, right? So in this case, these event tables, Dune does the hard work of translating the data for you, right? So I'm only showing this to you so you understand what's going on in the background. But typically you won't have to do this unless there's a contract that hasn't been decoded, and we'll talk about decoding. But I just find this is helpful because you're like, okay, I see where the data is coming from on chain. And maybe this isn't interesting, which is fine. But I think it's like, it helps with connecting things. And there are going to be times where you need to use these base tables to kind of put things together. But yeah, so that covers logs, traces, transactions, basic where function. Basic column function. Cool. So that's probably a headache to look through, right? And if data analysis all look like this, I don't think any of us would be doing this. So what we have instead is those event logs, right? So we're going to do some basic queries on this. We're going to use Rabbit Hole as our data set, right? So Rabbit Hole, just to kind of quickly explain what they do here, they essentially have these quests where, like, if you do a certain task on chain, then you'll get some sort of reward, right? These usually run in like some sort of interval, like 1 week interval. If you do it this week, then you get Aave tokens, right? So in this case, if you supplied some amount of tokens onto Aave, which is like this, you can think of it as like a bank essentially, like you're giving them a deposit. If you deposit into Aave, then you would get a certain amount of Aave tokens back. Specifically, I think they gave everyone like 0.05 Aave tokens, which comes out to around $15. All right. So I can see here, all right, that was the quest. This transaction shows basically the distribution to all these people who fulfilled the quest. All right, you can see they all got 0.05 Aave. If you're wondering why this is Polygon scan instead of Ether scan, just imagine Polygon is Ethereum at this point. I won't go into the nuances, but anyways. So we want to look at the fulfillers of the quest, right? So let's take this one. So instead of starting with like the Aave contract and finding the event hat, like a transactional, all that, whatnot, I'm going to just go through this data set here, right, and search up the event. So earlier we were on Ethereum. We're just to switch chains to Polygon for now. Again, don't worry too much about what the differences are. Just think of it as the same right now. So I'm just going to search up Aave event deposit. And it's going to show me there's this Aave v2 for some lending pool contract. There was a deposit event emitted, right? So I can click this and bring it over. So this is our table, right? Earlier it was Ethereum.transactions was our table. In this case, it's Aave.lendingpool event deposit is our table. All right, so let's just take a look. So I'm selecting all from. I'm going to do a limit 10 just so it's faster. And you can see like all of this data is already nicely parsed, right? All of the amount, like contract address, like a lot of the data from that event log is already nicely formatted for us, which saves us a lot of time. So what I can do here is I can say, all right, even though this is like a event formatted table, it still kind of follows it follows the table format of the logs, Ethereum logs table. So I can go to the right and I can still see like the contract that was interacted with, the transaction hash, the block number, and like block time, right? So let's say I wanted to look more at this transaction, right? Is this a good one? Yeah, so this is a good one. They have roughly, what is that, $500 or something? So I'm going to paste this here. That's way too many logs. Sorry. Let me pick an easier one. Let's do this one. All right, 25 logs. I can work with that. All right, I guess this is a good time to look through that. So earlier I was saying you sometimes have contracts that call a bunch of other contracts. And Natalia was asking like, oh, if GenieSwap calls OpenSea, does that, like, what does that look like, right? So in this case, you can see that there's a bunch of different calls kind of transferring happening. And we're really only interested in the deposit. So I need to find one that's just purely a deposit. Actually, maybe this one works. Okay, cool. We found we found an easy one. So here they're essentially depositing this Matic token and getting this Aave Matic token back instead, right? And what they should have called deposit, but they still didn't. Here, I might just go with the one I was working with yesterday. Give me a second. Did I have it stored? I'm sure I stored this at some point. Sorry guys, give me 1 second. Oh boy, I didn't store it. Alright, that's fine. Let me just... Alright, we'll do this the hard way. So what I want to look at here is essentially how did we get to this event, all right? And essentially you could show here that, all right, instead of looking for event.deposit, I could just look for the event topic, right? Sorry, I can't show this beautifully here, but what I can do is just Control F for it. So essentially, in the middle of this transaction, this deposit event was called, and you'll just have to take my word that this is the deposit event. And if I kind of selected all from here, this would give me the same exact things as the transactions here, right? Because these are essentially equivalent. And one way of backing into this is saying, all right, what is this address, right? This address is the Matic address, I believe. Right. And like what I could do here is I could search up for where deposit is emitted. All right. So anytime you go to some contract on Etherscan or Polygon Scan, you can look up the exact code of that contract. And I know I'm looking for this deposit event, right? Because that's named here. I can actually search through the contract for this event. All right, and you can see this event is emitting the reserve, which is the address of the token that's being used, right? So like USDC, for example. The user who is doing the deposit, behalf of, we won't worry about. Amount, this is the amount being deposited, and then this referral is like a referral code, right? And you can see there's 3 indexed index parameters, and then there's 2 non-indexed parameters. All right, so if I went back here, I can see that here we have 3 index parameters, and then here this is non-index parameters show up in data. And to make that more clear, I think we're looking at this row, right? So I should be able to check the user and the amount in this transaction. All right, so if I change this to address, that should match. Maybe I copied the wrong one. Sorry, you're seeing what it looks like to go through this live. 3A6. I took this one. Okay. Right. Oops. Oops. Clicking too fast. All right. So this was the user that deposited. This is how much they deposited. All right. And if I look at the event log here, that user matches, and if I change this to a number, this number is going to match as well, right? So hopefully that makes it clear how these tables connect. So what we want to look at is, all right, let's look at the people who fulfilled the quest. So what we're going to do here is say, all right, I want the users who essentially show up in this array of quest fulfillers. And this data was given to me by Rabbit Hole. So I'm going to copy this over here, where you can essentially see this is like a list of addresses, right? So if I run this, it's going to show me, all right, within the lending pool deposit kind of event table, so all the people who have deposited into Aave v2 on Polygon, which of those users or depositors are within this list of addresses, and only give me those results, right? I could take out the limit, because this should work quickly now, hopefully. Okay, maybe it won't. Let's do limit 50. I guess it's a good time to bring up queries will time out at 30 minutes. All right, so if your query takes more than 30 minutes to execute, that's not going to work. So you're going to have to find a way to basically get it to work in under 30 minutes. All right. So in this case here, let's just do limit 50. Cool. So that's going to give me 50, all right? Let's say I want to say, all right, who were the top, like what was the top 50 amounts deposited? So what I can say is I want to order by amount, all right? Let's say I do that. This is essentially saying, all right, I want to sort this order column. Give this a second. Maybe this actually takes a while.
Yes, you need to add descending as well if you want the top ones.
Yes, I was going to cover that. So on default, you're correct. On default, things sort in an ascending order, right? It's too slow to show, but I was going to show it's actually going to be really small numbers here.
I don't think the limit helps you too much.
Yeah, it's not going to work.
Like
And you can
everybody.
just use the subquery and then order it after that. Otherwise, it'll just sort the entire table and then it'll take up a lot of time. Just
Yeah.
use the subquery or OTT.
Yeah.
And then filter the results to a smaller subset and then order it.
Yeah, we haven't covered subqueries yet. But essentially, man, Polygon. Lesson learned, don't use Polygon for this. There's too many transactions. But essentially, you can imagine that this is going to order... it's going to order the amounts deposited, right? From highest to lowest. And you can also, sometimes it helps to filter by time as well. So let's say I only wanted to see if these users have deposited. Oh, there we go. That only took a minute. So you can see the amount here was actually low to high. All right, so if we had added, I won't let it run again, but if you added the descending, it's going to show high to low instead. Let's say I want to make my queries faster. I might only want to say, all right, I want those who deposited before or after a certain date. So in this case, let's do this. All right, so I'm saying, all right, I want people who deposited in this group within the last, I don't know, 1 month. Essentially what this is saying is take this column and make sure it's greater than now minus interval 1 month, right? So like 1 month earlier from now. That's one way to read it. Hopefully this runs quickly because I know we are coming on time. Okay, thank God. So that one ran a lot faster because now we didn't have to check the query didn't have to go and check for any of the deposits before a month ago. So you can see that ran in 2 seconds instead of or whatever the last one was. Well, order by. I'm actually curious. We'll get into subqueries next time as well. But yeah. So this is going to be a lifesaver for you. You're probably going to use in once in a while once we get into subqueries. But otherwise, for the most part, you're just going to be using like where like hash equals something, right? Yeah, so we can even see that this order by goes faster now that I'm limiting the time interval, right? It took 19 seconds versus a minute earlier. And again, here, I might as well just divide by the decimals, because this is still not divided by the decimals. Wow.
I don't think this makes sense here, though. There's going to be all kinds of different assets, no?
Oh yeah, you're right. It's not just USDC.
Yeah.
Which does get us into complications, but essentially you can imagine that this, once you are trying to figure out the amounts and you know the tokens, you can divide by decimals to get more sensical numbers. And what Boxer is saying is essentially we don't know what tokens are being deposited here. All right, so if I take this stuff out, each token address has its own kind of decimal format, unfortunately. Some of them are 18 decimals, some of them are 0, some of them are 6. So essentially we would have to do a bit of extra work to figure out the right decimals to divide by. But we'll get into that once we get into joins as well. Hopefully that makes sense. I've added 2 kind of beginner and intermediate guides that I think are like, if this makes sense, then I would just kind of go through these guides and see if that makes sense to you. And then you should be good to start working on some things. Cool. Any last questions? We'll obviously go through this in office hours a lot, or focus groups a lot.
Yeah, one quick question. When are you planning to put the recording on this so I can kind of go through it again?
Yeah, I'm going to be uploading it to our unlisted as usual.
Awesome.
Yeah, pretty much in probably an hour, I would say.
Sweet.
Yeah, and if anyone has any questions on this, again, this is a ton of material, I would say, to like wrap your head around, but I think like if you understand the basics of this, like you'll pretty much be good to go on querying across all of this stuff, because I think what I see a lot of people do is like they only query like Aave's stuff, right? And they get really familiar with Aave's work. But now it's like, oh, how do I combine like Aave deposits with like SushiSwap deposits or something? SushiSwap doesn't have deposits. Compound deposits. And then they get kind of confused, like, oh, how do these things connect? But like, if you understand these kind of 3 tables, then you'll basically have a good understanding of like, oh, okay, this is how everything all connects once I need to query across like much more complex queries. So.
Is the Dune window the only place to query it, or can we get the read-only access, the credentials to the database if that is possible, so that I can query it on Postgre on something?
Yeah, so right now Dune only supports querying in this window. I think that goes for pretty much every Web3 data provider. There might be a way around it if you use BigQuery, but if you use BigQuery, then you won't have this nice like event decoded format. You would have to decode all of it yourself. Cool. All right. Any other questions for now? Silence. Okay. I'm gonna assume you guys are all experts now. But yeah. So again, yeah, this was Web3 heavy Thursday we'll get more into SQL tools like aggregators and group by, and by the end of next week you'll have all the tools you need to really query across everything here. So that'll be fun.
Wait, I have a quick question
I have a
actually.
question.
Oh yeah, go ahead.
So as I said before, the balance of the hash or the address is maybe the byte format. So how to resolve it to string as the table show in the below?
Yeah,
Is
question.
there any way?
Yes, yeah. So Matt, do you want to ask your question while I set that up?
Yeah, that works. I was just wondering about you were talking about the ways to access the data before Dune, like the more basic things. Like I don't remember what they were called, but it was a slide of 3 things.
These ones?
And no,
Oh,
when
this
you're
one.
introducing Dune. Yeah, so like I get that probably for our purposes we're never going to look at anything besides data mappers, but what are we losing when we reduce the data? Like what would be a case where you'd want to use Node endpoints or Ethereum clients?
Typically the only reason you would use one of those is for if you want to interact with the blockchain. Let's say you wanted to send a transaction back, then you would need one of those. But otherwise, for just analyzing the data, you wouldn't really need either of these. The one caveat there is like if you know what a mempool is, or like if you've heard of Flashbots, the data they work with, you would need to run a client to be able to access. Because mempool data, essentially like pending transaction data, that's not stored technically in Dune or in the client even, because that's a lot of data. So if you wanted to do something like Flashbots or mempool analysis, then you would need to run a client. But there's a client or like a endpoint as a service. There's a great one for that one called Block Native. But otherwise, for analyzing finalized transactions, you're not missing anything by using like Dune.
Okay, cool. That's clear. Thank you.
Yeah. And going back to here. Right. So earlier, this was my address, right? Topic 2. So what I'm going to do is first I have to decode this essentially, or encode it, I guess, into a string. So what I'm going to do is take topic 2, encode it as hex, right? And this gives me this string. But now if I want the address format, then I would have to take the right, I think it's 46. Nope, it is not 46. 56? Oh, I went the wrong way. 44. Nope. 40. Right. And this would give me the address, right? And if I wanted, I could concat with /x, oops. All right, and then last step, since this is still a string, I would cast it to bytes format. Right, and then this gives me the address, and I will rename this to as from address. All right. So again, just walking through what happened here, I wanted to transform the bytecode into basically a string, right? So I'm just changing that column to a string, but there's a bunch of extra zeros, so I'm removing the extra zeros because addresses are just 40 characters long. And then I want to convert it back to bytes, so I add in that kind of byte operator at the front and then cast it at the end, and then I rename it to from address, right? So that's technically what's happening when you see this. It's because the team at Dune has already nicely done all of this for you, so that you don't need to do that, right? And I'll save this as well. Right. Does that make sense?
Yeah, thank you.
Yes.
Cool. I know we didn't really do anything flashy today. But again, I can't stress enough that knowing these fundamentals are going to help you a ton over the next few weeks. So highly recommend reading through kind of the extra resources I've linked in this as well. And I've put the link to this PowerPoint in the syllabus too. And it'll all be there as we go along, right? So if you go to the syllabus now, lecture 1 is linked, at least the PowerPoint. Cool. All right. I'm going to stop the recording.